Dan Linford, welcome back to the podcast.
I'm happy to be here.
So the claim that everything that begins to exist has a cause. Many people, or at least William Lane Craig, think that this is pretty obvious and common sense. And so before getting into specifics, the philosophical niceties, do you think that this premise, this claim, this causal principle, does at least initially have intuitive plausibility? Like if nothing else were said, you'd go, yeah, that's probably right. Or would you have more concerns about this claim that premise one of the Kalam cosmological argument, or the causal principle? Would you take issue with the claim that it's just common sense?
Right. I mean, I think what we consider common sense depends upon our background knowledge. But if we go back before anyone was doing science, and we suppose that we're, a bunch of people standing around in the Neolithic, and someone says, whenever anything begins, there's a cause for its beginning. If that's what we mean by common sense, like your pre-scientific knowledge, then sure. I mean that's part of our folk conception of the world. That whenever we see something beginning or when we see something altering, it's accompanied by some kind of cause, an efficient cause that explains the fact that that entity was produced or that change was brought about.
Right. So I guess to ground ourselves a little more, to get the context in place, this is the first premise of the Kalam cosmological argument, which reasons that if everything that begins to exist has a cause and the universe began to exist, well, then the universe has a cause. And so this is a part of a classically theistic argument, an argument for God's existence. And I wonder if you could say something about what philosophers mean by cause, because there are different kinds of causes you might talk about, like Aristotle distinguished four causes. Like in the context of the Kalam argument, what do proponents mean by cause here? Because it's not always obvious.
Right. So, and sometimes they don't bother to define it.
Right.
But as far as I've been able to determine, they typically mean something like an efficient cause. Right. So you mentioned that Aristotle distinguished between these four different kinds of causes. Sometimes today people say that, well, we really shouldn't understand all four of those as causes in our modern sense of the word cause. Instead, we should think of them as four different kinds of explanation. And then what we usually call causes in our contemporary discussion are what Aristotle called efficient causes. So an efficient cause is something that brings about some outcome or some result that brings it about that something exists, for example. Causes tend to be asymmetrically related to their effects. So a cause brings about an effect, but the effect doesn't bring about the cause, right? That's a kind of asymmetry. They tend to be local in particular. So if you are thinking about, for example, a brick breaking a window, like suppose someone throws a brick and brick hits a window and the window shatters, then in that case, it's the brick in particular that does the shattering of the window, right? It's not other things that happen to be in the environment of the window that have that consequence. It's the brick in particular that has that consequence.
Right.
We use those kinds of explanations all the time when we, for example, think about history. So, for example, if you're thinking about how the assassination of Archduke Franz Ferdinand brought about a world war, then it's, that's the one thing that is asymmetrically related to that effect, the world war, and which is the particular action that is credited in that case for bringing about that world war. It's not other things that happen to be going on in the universe. It's not, for example, the positions of the moons of Jupiter that brings it about that a world war happened. We tend to think that that's irrelevant for the world war. So when we think about those four Aristotelian causes, right? So we've covered efficient causation. There's three other kinds of cause or explanation that Aristotle thought about. One of them is what's called material causation. That's something like an explanation of something's existence in terms of the material of which it's composed. So, for instance, the material cause of a statue might be the clay that the statue came from. There's also what's called a formal cause. You can think about for example, people call mathematical explanation. Uh, so formal in this case is closer related to where we get the word formula.
Hmm.
And so if you think about some phenomenon that's explained in terms of its formal features, its mathematical features, its logical features, um, then you might be thinking about a formal cause. Um, and the way that Aristotle thinks about this is often in terms of like the formal cause of something might be something where we think about the nature that something has. Uh, Given the nature that something has, uh, there will be different formal features of that item that explain that item.
Right. Okay. So typically, then, in the context of the Kalam argument, we mean that everything that begins to exist has at least an efficient cause, something that
That's
brings
right.
its effect into being.
Sometimes, yeah, sometimes people define this. I've seen so Andrew Loke, for example, makes this move where he says that the way that we should understand the word cause in the causal principle is that either something has an efficient cause or a material cause.
Mm-hmm. Yeah. Right.
But that's a bit odd. That's a kind of odd way of putting it. Uh, so often, when you have a when you have some phenomenon for which you're going to give a disjunctive definition, this doesn't occur for all disjunctive definitions, but often when you have a disjunctive definition, um, there's sort of the suggestion that you haven't really picked out uh, like a mind independent category of things, right? You've kind of combined two things together that, as far as the world in its own right is concerned, isn't really out there. That's your mind that's grouped them together like that. Uh, and we might think that that's part of what's going on when, if we were to define causation in the causal principle in terms of the disjunction between efficient causation and material causation. Those seem like
Right.
quite different explanations. And it also seems like, the kind of explanation that's needed for the Kalam argument is efficient causation, right? Because the Kalam argument proponent is never going to say that the universe was made from pre-existing materials.
Right. Well, okay, so we can follow this tangent a bit. Craig has endorsed that move too in his 2009 paper, in the Blackwell Companion article, and I think Graham Oppie levels that same complaint. It's like, okay, well, if you're going to allow that potentially material causation counts for being a cause, even without efficient causation, that leaves open the possibility of a material cause for the universe. And Craig's response is, well, not really, because if you show that the universe has an absolute beginning, then it cannot have a material cause. And so therefore it has to be an efficient cause. So while it's left open in the general sense, when you apply it to the universe and an absolute beginning thereof, there's no worry about a material cause. The category just can't apply.
Yeah, so we might worry, though, about, for example, the empirical generalizations that support the causal principle.
Sure. Okay.
So often, when you give a disjunctive definition, um, one of the things that can happen when giving a disjunctive definition is that your base of examples from which you make your empirical generalization or inductive generalization doesn't actually support the principle that you think that it does. Um, right. So this is well, and this is closely related to this problem about like gruesome predicates.
Hmm.
So for the audience that doesn't, if the audience doesn't know, you consider a statement like all emeralds are green. That's a statement for which we supposedly have an empirical generalization. Putting aside the fact that the term emerald contains within it the idea of greenness, but set
Right.
that
Right.
aside. Suppose we have like some family of rocks, and we're saying that members of this family are green. Um, that's one way to think about. That's one predicate that you could have a inductive generalization for. But
Mm-hmm.
another one is this a predicate that we might call GRU, where something counts as GRU if it's either green or blue. And now it seems like we do have good inductive case for green. We don't have a good inductive case for GRU, and part of the new problem of induction was trying to say like what is it in virtue of which those two predicates differ. And typically people think is that, well, it might be difficult to say precisely what it is in terms of which those two terms differ. There has to be something, because if there weren't, then induction's not going to work in the way that we thought that it should.
Right. Well, this forms a nice segue into the three lines of defense typically given by Kalam proponents for the causal principle. We'll go in reverse order because it makes more sense at this point. In that case, the first would be that it's a plausible empirical generalization. We can reason inductively, we can follow enumerative induction specifically, and say something like, well, every observed thing that begins to exist has a cause, as far as we can tell, and therefore we can infer by enumerative induction to the general principle that everything that begins to exist, whether observed or unobserved, has a cause. And on its face, this is just an instance of the general enumerative induction schema that all observed A's are B's, therefore all A's are B's, whether observed or unobserved. And I'm gathering what your response will be, but okay, with that context in place, what is your response to that claim? It's going to be group predicates.
Yeah, right.
Is that the one main issue?
So that's not what I would take to be the main issue. I mean, I would first of all say that we should charitably interpret the causal principle as being about efficient causation. And then the question that we're asking is, do we have a good inductive case that anything that begins to exist has an efficient cause? And the idea that for every instance of something that begins to exist, there's some cause that we can, there's some associated cause. That inductive generalization, I think, is it's just false that we have that inductive generalization. And in fact, there's a position that's been around in the philosophy of physics for quite a long time. It's a position that's popular both in naturalistic metaphysics and in philosophy of physics more generally. By the way, by naturalistic metaphysics here, I just mean a way of doing metaphysics that draws upon the sciences,
Right.
as opposed to armchair metaphysics. I don't mean a position that there's only the natural world.
Right.
But anyway, among people who do their metaphysics in that way, by drawing upon the sciences, there's a position that's been quite popular that we should be able to give a physical account, a reductive account of causation. This is a position called neo-Russellianism, named after Bertrand Russell. But there's that neo prefix at the beginning. So it's not quite Russell's position, it's a modification of Russell's position. So in 1912, Russell published a paper called On the Nature of Cause. And in that paper, Russell argues that causation is missing from physics. Sometimes his view is summarized as the position that physics makes use of differential equations and not causation. That's part of what Russell argues, but not the whole thing. So what Russell actually argues in that paper is that causation is missing from physics, not just because physics is written in terms of differential equations instead of causation, but also because the differential equations that physics is written in terms of shouldn't be interpreted in causal terms. Right? So usually in a physical theory we have two things. We've got the mathematics on the one hand in the theory, and we've got the interpretation of the mathematics on the other. And so if someone were to show up and say, okay, well, this theory is written in terms of mathematics, where's causation? Well, someone could turn around and say, well, at the step at which you interpret the theory, we bring causation back in. But what Russell's going to say is that that's not the right way to interpret our best physical theories. Russell didn't think that it's not a claim about randomness. The claim isn't that that physics is about like random occurrences or unexplained occurrences. He thinks there are explanations, and in fact, the view that he gives in the paper is completely deterministic. It's just that what determines different events, what explains their occurrence, is not going to be causation. It's going to be something else. And so that's what Russell's position was. Neo-Russellianism, like I said, isn't quite the same thing as Russell's position. So in between the appearance of the neo-Russellians and Russell, there's another figure that comes on the scene, Nancy Cartwright. So Cartwright argues that we need causation after all. That there are sciences that can't make do without causation. So, for instance, we might think about medical studies and the way that medical studies are related to interventions that we can perform in order to bring about some desired outcome. So, for example, let's suppose that we knew that there was some correlation between cholesterol levels and heart disease. Now, if you want to reduce the incidence of heart disease, you might think that what you should do is to make some intervention on cholesterol levels. You might try to change or bring about a change in people's cholesterol levels. But in fact, it's only going to be a good intervention if there's a causal relationship between the cholesterol levels and the heart disease. So if those two variables are, for example, both brought about by a third factor, then intervening on any one of them isn't going to change the other. So we need more than just correlation. Cartwright would say we need, in order to know which interventions are effective, in order to bring about effective strategies, she would say, we need to know information about causation. So the neo-Russellian takes into account both views. The neo-Russellian says, at the level of fundamental physical explanation, when you come down to the rock bottom in the way that physics is going to explain all other parts of the natural world, at that level we don't find causation. However, when we think about large-scale objects, like human beings, or the sorts of things that medical doctors study, even many of the things that are studied in, say, chemistry, then we need to know about effective strategies, and at that level we are going to have real causal relations. Now what that looks like then is a reductive picture, where at one level of explanation you have some phenomenon, namely causation, that you don't find at a more fundamental level. Now if the neo-Russellian is right about all of that, and if they're right that that's the right way to understand our scientific picture of the world, a picture for which we have vast amounts of evidence, then it's not going to be true that we have some wide-ranging inductive generalization that anything that begins to exist has a cause. There are some caveats there. So here's one way that you could maybe escape this. You could say, well, many of these neo-Russellians think that another thing that's missing from fundamental physics is a direction of time. So the difference between the past and the future. That's another feature of the world that comes about at a higher level, but you don't find fundamentally. If that's right, then perhaps microphysical things don't begin to exist. And then they wouldn't be a counterexample to the causal principle after all. Perhaps. There is also the suggestion that if you have a macrophysical direction of time, then you could maybe still say that microphysical things begin to exist if they have finite temporal extension in that macrophysical past direction. But at any rate, if that were the way that you were to go, you would say that the causal principle turns out to be true, but only trivially so or vacuously so, because there's no instances of microphysical things that begin to exist. Then what you'd also have is some reason to reject the other premise of the Kalam cosmological argument, right? You'd be able to reject the idea that the universe began to exist, because there'd be a level of an aspect of the universe that's beginningless.
So what is the reduction though on the neo-Russellian picture? What you said it offers explanations for things but not causes. So fill that in a bit. What is it doing if not causes?
Right. So maybe the easiest way to go about explaining this is to look at how Russell thought about the issue and then sort of update the picture for how we think of physics now. So in 1912, Russell is thinking about Newtonian physics, about pre-relativistic and pre-quantum mechanics, and he thinks that even at the level of Newtonian physics, we don't have causation. Well, why is that? Well, remember what I said, one of the things I said about how efficient causation is going to work. It's going to be asymmetric, that causes are related to their effects in a way that effects are not related to causes. And it's going to be particular, that it's the brick that breaks the window, not the positions of the moons around Jupiter. Well, it turns out that in Newtonian physics, if you so the formal structure of Newtonian physics is such that the past is related to the future in the same way that the future is related to the past. So over time, you don't have any symmetry. It's also going to be true in Newtonian physics that if you take the world at a time, so two things that are going on simultaneously, we don't have the appropriate asymmetry there either. So either kind of asymmetry that you might have wanted, either an asymmetry over time or an asymmetry at a time, are missing from Newtonian physics. You're also missing this requirement that the causes be particular. So it turns out that in Newtonian physics, the positions of the moons around Jupiter are going to be just as important, as far as those equations are concerned, for breaking the window as the brick. So at the level of Newtonian physics, if that were your fundamental picture of the world, then you're not going to be able to say that there's some particular thing in the past of an event that brings about that event. Rather, it's the entire past of that event that's responsible for bringing about that event. And you're not going to have the asymmetry either. And so the idea was that the formal structure of Newtonian physics is incompatible with an interpretation in terms of efficient causation. All right, well, what about, how do we update this picture for modern physics, or a contemporary physical picture? Well, in relativity, there's no such thing as objective simultaneity. So in Newtonian physics, we're able to take the world at a time. You take two events that are at some distance apart from each other in space, and then we can say that they nonetheless exist at the same time. In relativistic physics, at least as standardly construed on the kind of four-dimensionalist relativistic picture, there's no such thing as the world at a time. Instead, there's the closest that you're going to get is what's called the past light cone of a given event. So this is going to be all of the events to the past of a given space-time point that can send a signal to that point. And it turns out that the entire past light cone is all parts of that entire past light cone are equally important for what happens at the point in question, at the vertex of the cone. There's one other way that you could think about the development of the world over time in relativistic physics. So in some space-times that are compatible with general relativity, that are compatible with Einstein's theory of gravity, you can slice space-time up into what are called Cauchy surfaces. They're not instants of time, but they're similar to instants of time in that if you know everything that happens on one of these surfaces, then you can calculate what will happen on any other surface. But just as the past is related to the future, and some of the future is related to the past in Newtonian physics, so too any one Cauchy surface suffices for determining what happens on any other Cauchy surface. And again, like those are entire, the Cauchy surfaces aren't some small regions of the world. They're entire huge space-time regions. And so you don't have, again, the kind of particularity that we expect out of causal explanation.
It seems to me that the argument there is predicated, at least first in any case, on a naturalized epistemology, or on a naturalized metaphysics, where we are actually, before I even tell you what I think that means, could you flesh that out a bit more? What is a naturalized metaphysics? I think that lies at the foundation of this argument. I think it's really important. So what is
right. So there's a number of different approaches that one could have to metaphysics. A sort of standard approach, an approach that's been standard among certain groups of philosophers for the past, say, 200 years, is this view that we're going to have a distinction between things that are, let's say, observable and things that are not observable. So the way that things are in themselves isn't directly observable. And so the way that things are in themselves is going on this conception is going to be the domain of metaphysics, and then the things that we can sort of directly observe is going to be the domain of the sciences. That would be this way of dividing up metaphysics that roughly comes out of Immanuel Kant.
Right.
However, for a much longer period of time, there's been another approach to metaphysics, an approach you might find in, say, Aristotle, where metaphysics is not going to be this activity that's divorced from the sciences. I mean, the reason why Aristotle's book, Metaphysics, is called Metaphysics has nothing to do with whether Aristotle thought that it was some picture that is like, that transcends our picture of nature or something. Instead, or that transcends our picture of physics. Instead, Aristotle, his book Metaphysics is called that only because it was the book that came after the book that gets called Physics. So many years after Aristotle, when people are sitting around and trying to divide up the Aristotelian corpus and giving names to each one of these things, the name that they give to the metaphysics, they give it just because it's the book that comes after the physics. In Aristotle's view, there isn't going to be this really sharp divide between a metaphysical study of nature and a scientific study of nature. Today's naturalistic metaphysicians you can think of as in some sense continuing that Aristotelian tradition. They're not doing metaphysics in Aristotle's terms, so they typically aren't themselves Aristotelians, but they like this idea from Aristotle that metaphysics is going to be about trying to come up with a conception of the world, of what exists in mind-independent reality. And the way to do that, most naturalistic metaphysicians are going to say, is not by sitting in your armchair and thinking about concepts in their own right, but rather by going out and seeing what the scientists have to say, being engaged with the sciences, and formulating your metaphysical theories as a kind of extension of or in continuity with the sciences. Right? So in this case, the idea here is that we're going to look at the way the scientists deal with causation, and then we're going to come up with a theory of causation based upon what it looks like the scientists are doing.
To what extent does the naturalized metaphysician attribute independent content to metaphysics? I would struggle on this view to differentiate the metaphysician from just the thoughtful physicist. Like, if there's no fundamental difference in the methodology between metaphysics and physics, metaphysics and science, like what is the office of the metaphysician? What are they doing that the scientists themselves don't already do?
So I think there's not going to be a difference in kind, but that doesn't mean that they're the same activity, right? So we can think of them as both existing on the same spectrum. Sometimes the way people talk about this is that metaphysics is going to be continuous with the sciences, that we're not going to find some like categorical distinction between the two that easily cleaves them apart, but nonetheless, they have distinct locations on this spectrum. And sometimes what's going to happen is that you'll have a scientific project that might look like metaphysics, or you'll have a metaphysical project that might look like science. And it might be that the only way to tell them apart is something very superficial, like which department at a university the person happens to be in.
Okay. I'm not sure what I think. I mean, this is a question of metaphilosophy, right? Like, what is the nature of philosophy? And I'm assuming that when we talk about metaphysics here, do naturalized metaphysicians, they probably extend that to every area of philosophy. So they would advocate like a naturalized philosophy, right? It's not like they would allow for epistemology to proceed independently of any empirical data and to come into conflict with science, right? Like, this is meant to be a description of philosophical methodology and nature, right?
Well, so being committed to naturalistic metaphysics doesn't commit you to a broader naturalistic thesis about philosophy generally. It will be true that many people who find naturalistic metaphysics attractive are going to adopt a similar stance in other parts of philosophy. But, there are going to be people who maybe they think, for example, that the domain of ethics uh, can't be brought together with the descriptive domains, right? So there's this classic distinction that we might think of as coming out of someone like Hume, where the descriptive and the normative are really going to be two independent things, right? So when we talk about Hume in this case, people call this the is ought dichotomy, right? So to give a description of the world is this wholly different activity than saying what you ought to do. And so if someone endorsed that kind of distinction, then they might say that, well, metaphysics is something that should be continuous with the sciences, ethics is not.
I wonder how sustainable that view would be, that bifurcation between, say, naturalized metaphysics on the other and a non-naturalized ethics. I mean, if you allow for like strictly philosophical sources of rational belief, like say they would allow for belief in fundamentally evaluative facts that science can't recover, but we have philosophical warrant for. I mean, doesn't that open the door in principle to say the exact same thing in metaphysics about, say, the arrow of time or causation? Yeah, physics doesn't capture these things, but we have good philosophical warrant. In the same way, whatever it might be for evaluative facts, we have the same kind of warrant for belief in causation. It stands
Well,
on
we have
philosophical grounds, even if not in
so we have
physical on
scientific
physical
theorizing.
grounds.
Yeah, so we have scientific theorizing, and part of the question here, one of the relevant question is what exactly is going to be the distinction between scientific theorizing and, say, fundamental physics and metaphysical speculation. It's difficult, in my mind, to see how there could be a distinction between some firm, like, categorical distinction between those two activities. I mean, put it this way: a big part of what we call metaphysics is a subdiscipline that we call ontology, and ontology is something like the study of what exists. Right? So if you come up with like a list of all the things that you take to exist,
Right.
then you've produced an ontology. Now, where do we get information about what exists? Well, one way we could get information about what exists is by going out in the world and cataloging, like looking to see what exists. And if you think that that's the sort of the best method that we have for figuring out what exists, well, then you're going to say that your best way of doing ontology is by doing science.
This is a tangent, and we'll reel it back into the Kalam argument for sure. But this is interesting. I'm very intrigued by like metaphilosophical questions, like what am I doing as a philosopher, and how does it relate to science? It's very intriguing to me. But take what you just said about ontology. Like this is this subdiscipline of metaphysics. It's cataloging what exists, and how do we determine what is within that? What exists? Well, we have physics. But if you allow for ethics or meta-ethics to have fundamentally evaluative facts that science doesn't capture, well, that refers to something that exists. It would seem that that is perfectly fine and rational, even though science can't capture it. Well, maybe that happens in more traditional, tried and true metaphysics. There are just going to be some things that physics doesn't capture.
Sure, but in that case, I mean, could we reinterpret what we're saying as the claim that uh, there are various statements that we can know to be true because they follow from theories that we take to be more broadly justified? I mean, the claim that science and philosophy, or science and metaphysics in this case, are categorically distinct is going to say that there's some very thick distinction between metaphysical speculation and scientific theorizing. And that's where I sort of lose track of what exactly that distinction is supposed to be.
I agree with you. There isn't going to be a hard and fast distinction between the two. It's difficult to cash out, and it comes up in like the more clearly interdisciplinary debates. One of which is going to be philosophy of space and time. The other would be the fine tuning of the universe. Like how do we explain this? Well, that is going to be a conversation that involves both philosophers and scientists. but you'll still have this question of like, what are our sources of warrant or justified belief in this debate? Like, is it just what can be empirically verified or whatever we might want to call scientifically verified? Or is there a means, a source of justification that is not recognizably scientific, but is still rational? I'm open to that. And I wonder, can the naturalized metaphysician, can they really say that, or do they really have to bite the bullet and say,
So
no, it's really just what science gives us?
they don't have to be verificationists or even like very strict empiricists, right? So if you take someone like Quine, for example, Quine and Putnam were both committed to the reality of mathematical objects. They're committed to a kind of mathematical realism. The reasons for thinking that was because they thought that our best scientific theories existentially quantify over mathematical objects. So, in other words, there were statements in our best scientific theories to the effect that, there are such things as numbers, but numbers aren't going to be themselves physical objects. And so you could imagine someone who thinks that there's that there are non-physical or immaterial
Right.
realities that the sciences sort of indirectly give us access to. Um, Something like this, in fact, happens with many of the Kalam cosmological argument proponents, right? So Craig is sort of an interesting case where if what Craig has to tell us about the Kalam argument is right, then it really seems like or at least if the scientific case for the Kalam argument is correct, then it really seems like the naturalistic metaphysician should be a theist, right? So
Right.
this is one of the important distinctions here because often because there's two different things you might mean by naturalistic metaphysics, right? One thing you might mean by it is that metaphysics is continuous with the sciences, and that leaves completely open whether God exists, for example,
Sure.
because you could have scientific evidence for God. The uh, the other thing sometimes people mean by naturalistic metaphysics is the view that all that there is the natural world, and the naturalistic metaphysician in the former sense is not committed just by definition of their view to the latter thesis, right? So as far as the naturalistic metaphysician is concerned, there could be all kinds of things that are unverifiable by scientific methods that we could nonetheless know about, or that all sorts of things that are not physical or that are immaterial that we could know about, maybe indirectly by seeing how they, say, affect the physical world. A naturalistic metaphysician could be a scientific realist. In fact, if they're doing naturalistic metaphysics, it's kind of hard to see how they could be doing what they're doing unless
Right.
they're a scientific realist. And but the scientific realist is committed to the view that there's all sorts of things that we know about, but that we can't directly see, for example. Um,
So I think we would be remiss if we didn't discuss the like main line of support appealed to in defense of the causal principle. It's got a lot of intuitive pull, and that's that something cannot come from nothing. Now, in the context of like the universe as a whole, if the universe began to exist without any sort of cause, then that would seem right. It came into being from nothing at all, meaning it did not come from anything. And that's a tough pill to swallow. So I'm interested to see how the neo-Russellian would look at this, how they might reduce the counterintuitiveness of this claim. But I think for many of us, if we're told that the universe just came into being from nothing at all, that's tough to wrap one's head around, if nothing else. So what about this claim that something cannot come from nothing? If something comes into being, it's got to come from something. However we might cash that out. Back to you, Jan.
yeah, so there's a number of different things to be said here. One of the first things to say is that it's not, there's a kind of ambiguity in what exactly the claim means. So if it's the claim that something can't come about without a cause, then it seems like the causal principle and the statement that something cannot come from nothing, are just equivalent statements. But if instead we mean that anything that begins to exist must be, say, made from pre-existing materials, well then uh, the theist picture of how the universe came about isn't possible either, right? Because the theist picture is that God made the universe ex nihilo, uh, and if anything that begins to exist requires a material cause, that it requires to be made from pre-existing materials, well then ex nihilo causation isn't possible. All right, but let's put that to one side and see if there's something else that the neo-Russellian in particular could say, right? Because the two responses I've given so far are not responses that are particular to the neo-Russellian. One thing they could say is that at the level of fundamental physical explanation, the past depends on the future in the same way that the future depends on the past. Now, depending upon what they say about the reduction of the direction of time, one possibility is that if the direction of time is completely reduced so that fundamentally there is no direction of time, then fundamentally the universe didn't begin to exist. But on the other hand, if we are still allowed to talk about the beginning of the universe, well, the neo-Russellian is already committed to this view that we don't have the kind of asymmetric causation that the Kalam argument proponent seems to be committed to, right? So in other words, a future state of the universe, for example, could be what explains the initial state of the universe. It's not that the future state of the universe would cause the first state of the universe, but rather that there is a lawful connection, a nomological connection between the initial state of the universe and subsequent states of the universe.
Okay, that's intriguing. I don't have any profound thoughts on it because this is new to me. Do you understand the gut level reaction that people have to claims like that? I mean, just even take that last claim you made that like a later state of the universe explains an earlier state. I have sympathy for the reaction that goes, okay, I don't know quite how or why, but we've gone wrong somewhere. That like this is a tough, if this is what, say, the neo-Russellian view implies, that's a real cost for the view. Obviously, it's always difficult to tell, like, have we really created a reductio ad absurdum, or are we just saying an implication of the view, and I accept that implication. But do you understand that gut level, like, meh, what does it even mean to say, like, a later state of the universe explains the earlier state?
Right. One of the really important parts of our immediate access to the world is that it is this kind of asymmetry of time. But that asymmetry is already thought to have a reductive explanation. And its reductive explanation is going to explain why it is that that's how we encounter the world. So we encounter the world in such a way that it seems like for us to make interventions on our environment, the kinds of interventions that we know how to bring about are ones that, when you act at a particular time, they make some change for the future. It's not part of our ordinary experience that we make an intervention in the world and it brings about some effect in the past. But that fact, as I was saying, has to do with the fact that we are these like large-scale objects that are situated in the world in a very particular way. So when we think about that asymmetry, maybe here's a way to think about it. Suppose you have a crowd of people, and what we want our crowd of people to do is to knock over a bus. Now, everyone in this crowd runs at the bus from different directions. They're all it's a big disorganized crowd. The bus might jiggle around a bit, but it won't fall over. They won't be able to knock it over because they don't have they haven't like combined their strength together in the right sort of way to push the bus over. But suppose that instead what we do is we organize the crowd so that everyone runs the bus from the same direction. And now if we have enough people, the thought might be that they actually can collectively combine their powers together and knock the bus over. Well, something very similar happens with atoms. So if you have a piston and you have a gas inside of your piston and you want the gas to do work on the piston to expand the piston, then the atoms in the gas have to have a particular kind of organization, just as the people in the crowd had to have a particular organization. Mm-hmm. But if you think about all the different ways that you could organize atoms in a gas, the vast majority of them are going to be ones where you can't do work to push up that piston, just as all the disorganized configurations of the crowd can't push over the bus. Now, what that means is that if you, at one point, have the atoms in your gas in an organized configuration, then what you'll typically see is that the gas will evolve into the future in such a way that it will go into a more disorganized state. And that's what physicists call the second law of thermodynamics. And people might know that when we talk about order and disorder in this sense, the kind of order that you need to do work, well, that's what we call entropy, right? Or rather, it's the opposite of entropy, right? The entropy is the amount of disorganization in the version of the gas that's unable to do work. Whereas what's called the free energy is the amount of energy that you have, the amount of like sort of organized energy that you have, the amount of energy you can put into doing work. Now, if you pluck a system at basically random out of nature, and you let it evolve forward through time, then what you're going to typically see is that that system will go from a lower entropy configuration to a higher entropy configuration. Well, why would that be? I mean, if most configurations that you could possibly have of a gas are disorganized configurations, why is it that when you pluck one at random out of the universe, it tends to be an organized one that proceeds off and becomes more disorganized? Its entropy increases. Well, let's think about the kind of access that we have to the past. So one way you could make a record of the past is by taking a photograph. So think about what happens when you take a photograph using an old-fashioned camera that uses like a photographic plate. Your camera begins in a state where the shutter is closed but cocked. You're like ready to take the picture. Then what happens is that you open the shutter and the photographic plate undergoes an irreversible chemical transformation, and then when you close the shutter again, the picture is left there. Well, how did you know that you began the camera in that state where it was ready to take a photograph? Well, presumably you had some other record of the camera having been in that state. Right? Now we have an infinite regress of states of ever lower entropy going into the past. That huge chain, it turns out, is going to terminate in what has sometimes been called the mother of all ready conditions, some low entropy condition for the entire universe, a state of which, because it's the first one, it wouldn't be possible to have a record of it, right? But it explains how we could have records of everything else. That's what people call the past hypothesis. And it turns out that if you want to have explanations in the vast majority of the sciences, what you have to do is you have to assume three things. One is that the universe began in that low entropy configuration. The second is a claim about the probability distribution over the space of possible states. And the third one is the third condition, the third principle is the fundamental laws of physics, whatever they ultimately turn out to be. That combination, the package of three principles, is what's called the mentaculus. And the thought that many people have had is that you can't make claims about chances unless you conditionalize your probabilities on the mentaculus, on that package of three principles. Now, The standard thought is that any of the asymmetries that we encounter in everyday life, including, for example, the causal asymmetry, are going to share that reductive explanation with the second law of thermodynamics. That package, that mentaculous package, is going to explain why it is that we encounter the world as having this causal asymmetry. One of the things to notice here is that what's sort of peculiar about the views of many theists is that because they don't have a reductive explanation of causation, there's going to be a feature of the world that theism doesn't give them an explanation of. Right? I mean, usually it's supposed to be that the advantage that theist has is that they can explain a whole slew of different things in terms of theism. Right? This is why, for example, Leibniz has this argument for God's existence in terms of the principle of sufficient reason. But in this case, it's the naturalist that has a particular kind of advantage, because they're the one that can give this like physical explanation of causation and why we encounter the world in the way that we do, and why we find these asymmetries all over the place. That's just not going to be available to the theist.
Well, Dan, much to think about. These are really interesting questions, and I know almost nothing about neo-Russellianism, but I am now, as a result of this conversation, I'm realizing I need to bone up on my understanding of the literature and the view. Because I think it could be right, even though my gut reaction is to say absolutely not. But you've given me more food for thought on it, so I appreciate that. Thank you for coming on.